Hello students, in this lecture we are going to cover PDA for the context-free language having different input and stack symbols, and we have already covered this example in lecture 51. So we are just covering the same example to clear the concept of different stack symbols if mentioned in the question paper. Okay, so if we have this type of statement given in the exam, construct PDA for this language where we have W string of A's and B's. So we can say that input symbols are A's and B's here, and the stack symbols are also mentioned here as stack symbols Z0. Z0 is a default stack symbol. Another stack symbol mentioned here are X and Y. Okay, so now as in the previous question, for this question we have already covered that the minimum string is C. If the W is null, then the minimum string to be accepted is C here. Other minimum strings are ACA, BCA, okay, and other minimum can be A, B, C, B, A, etc., etc. So next, if the string is null, then we have to accept C only, and we need not to push anything on the stack top. Stack top will be Z0 only throughout the complete string. But if we have any other pattern, then we were having the push operation for the symbols received with the before the C onto the stack top. So here for this string, for example, we are taking this string, so we were having push operation on the stack top as the initial stack top is Z0. So we were having push operation for first A and then B, for A and then for B, then on C we were moving from initial state to the next state to perform the pop operation of A corresponding to the stack top A and B corresponding to the stack top B, replacing it with null. So we were doing this process in the previous lecture, in the lecture number 51 for the same question. Now as we are given with the constraint of using X and Y as a stack symbol, so we cannot push B and A onto the stack top. Now instead of B and A, the approach will be same, just we need to push the X and Y onto the stack top. So Z0 is a default stack symbol, we cannot change it, but now we have to use X and Y as a stack symbol, not B and A. Okay, so here we are defined with different stack top symbols. So here suppose I have defined X for A and Y for B. Okay, so it's up to you, you can define Y for A and X for X for B. So here I am using X for A and Y for B. So wherever we need to push A onto the stack top, we will be using X. Okay, rest process is completely same. Here instead of B, we need to push Y onto the stack top as we have given with X and Y as a stack symbol, not A and B. Okay, rest approach is same. So let's start with the question here. Here are the initial transition to push the initial symbols onto the stack top. If the first symbol is A and the stack top must be Z0, then we were having this transition. Okay, so now instead of this, we have to push A onto the stack top, but this time we cannot use A as a stack symbol. So instead of A, we just need to push X onto the stack top, and rest transition are same. Okay, now for B, we have B as a input symbol, Z0 as a stack top, and we have to replace or push B onto the stack top. So here instead of B, as we were writing B in the previous lecture, so now we will be writing Y Z0. Okay, rest is same, just instead of X, instead of A, we will be using X for the stack replacement and Y for the B stack replacement. Next, to push, if we are having input A and the stack top is A, so for that we need to check for X. Okay, and if input is B and stack top is also B, for that we need to check B as input and stack top as Y, because Y is now representing the stack symbol B. Okay, so here are the corresponding transition. If the input is A and stack top is X, replace it with double X. So here double X mean we are pushing, as we were having this transition, replace it with double A. So here instead of double A we are writing A as input, stack top is X, now replace it with double X. So here double X are representing double A. Same way double Y here are representing double B. Two B simples are represented by double Y here. So rest are same. If we have the combination, means A as an input string and Y as a stack top, means B as a stack top, then we need to push X Y. Okay, X Y, X for A and Y for B. Same way, if we have B as an input symbol and the X as a stack top, then we need to push Y X onto the stack top and replace the string. So here are the corresponding transition. If we are having input as A and stack top as Y, Y means B and input is A, stack top is A. Input is B, stack top is A, then we have to push or replace X with YX. So these are the corresponding transition for all possible push operation before C. And once we received C, we need to change the state from S to A. And for C, we have three possible option of stack top. If the minimum string is C, then we are having stack top as Z0. If the input is C and the minimum string is ACA, suppose we are taking this as a minimum string, then the stack top is A, and if the symbol before C is B, then in that case we will be having B as a stack top, right? But here instead of A, we will be checking for the X, and instead of Y we need to check for the B, instead of B we need to check for the Y. So if the stack top is C, input is C and the stack top is Z0, or if the input is C, stack top is X, or the input is C and the stack top is Y, we just need to change the state from initial state to another state A without changing the stack top, because we need not to match C with any input symbol. So we can keep the same stack top for C and just can change the state. So here are the corresponding transitions. For C, if we are having Z0 as stack top, replace it with Z0. If stack top is X, replace it with X, and if the stack top is Y, replace it with Y and change the state. And now on A, we have to simply perform the pop operation as we were performing. Input is A, stack top is 8, replace it with null. Now we have to check input is A and stack top is X, replace it with null. Input is B, stack top is Y and replace it with null. Okay, so we need to perform this as a pop operation here. So here we have A, input is A and stack top is X, replace it with null. And if the input is B, so here we have B, not Y. Input is B and stack top is Y, replace it with null and move to the next state. So here if the input is null and stack top is Z0, and we are having the final state or the acceptance. So here we have A and input is stack top, stack top is X and replace with null. Okay, so here we are not having X, here we are having A, and here we are having B and stack top is Y, and move to the next state B or the acceptance by final state. And this is the way how we use a given stack symbols for every push and pop operation. We will not be using the input symbols anymore if the stack symbols are mentioned in the statement. So in the next lecture we will be discussing about the context free languages, pumping lemma for the context free languages, and what are the applications of pumping lemma. Till then, bye.